Welcome DKW 配小工 aboard. Your learning journey starts now. Ever wondered if your phone could actually know what you want before you even ask? That's the million-dollar question in the intention economy. We're moving beyond just grabbing attention. Now, AI needs to truly understand users. How? By cracking the code of user modeling and intention recognition. Let's dive in. So, how does a machine get from a click or a search to understanding your desire? Think Wheeler's it from bit. Every action is a bit, a tiny piece of information. Intention recognition is like assembling these bits into a coherent picture of intent. But here's the kicker. Landauer's principle tells us there's a physical cost. Every calculation, every data crunch burns energy. Delta E is greater than or equal to kBt times the natural logarithm of R. It means we can't just throw infinite computing power at this and expect perfect accuracy forever. There's a thermodynamic boundary to how much we can squeeze out of raw data. It's not just about algorithms, it's physics. Okay, so how do we build this understanding machine? We stack it up in 5 levels. First, multimodal perception. Gather all the signals, clicks, location, voice, whatever. Then, natural language understanding. When you say book a restaurant, NLU gets it. Next, context awareness. Knowing it's noon and you're in the office changes the meaning of opening a food app. Fourth, behavioral pattern modeling. Spotting that your browsing phones implies you might buy one, using RNNs or HMMs. Finally, user profiling, building a long-term knowledge base of who you are. Each layer builds on the last, creating a comprehensive view of your digital self. Now, remember that energy cost is not just a footnote, it sets a hard limit. Processing information isn't free. Plus, like quantum mechanics, there's an uncertainty principle at play. Some human intentions are inherently fuzzy, ambiguous, maybe even unsolvable by any model. You can't have 100% precision. So, the game is finding that sweet spot, complex enough to be useful, but not so complex it melts the server or ignores the fundamental limits. Without solid intention recognition, AI risks semantic drift, drifting off course from what you actually wanted. It's the prefrontal cortex of the agent, keeping it aligned. So, we have the framework, but the roadblocks are real. Computational cost is huge. Efficiency matters more than just bigger models. Data has boundaries, privacy laws, and noise mean less is often more. Can we even explain why the AI thinks you want X? That's the trustworthiness challenge, and balancing stability with adaptability is key. The big question now is, if we can read intention, can we execute it? That's where things get really interesting.